Hello. Now we are going to look at compound interest. So if we imagine that we put a certain amount of money into the bank, say €1,000, the bank will offer us a particular interest rate, a particular amount that they're going to pay us at the end of each year for having left the money with them in the account. So they calculate they can make a particular amount of money on it, and they give us a certain amount of that as interest. They effectively pay us to store our money with them. Or if we took out a loan, we would have to pay them interest. So our loan, the amount of money we would owe the bank, would go up each year by a particular percentage. So this is how our banks work a lot of the time. And we are going to look at how these calculations get done, how it is we work out the amount of money we would owe if we had a loan, or the amount of money we are going to make each year if we have invested money, and we're going to get interest from that investment. So the formula that we are going to use is on page 30 in our log tables, in our formula tables, and it is the final value, the final amount in our account at the end of the year is going to be equal to the amount we started with, which is called the principal, multiplied by, so bracket for multiplied by, 1 plus the interest rate written as a decimal, bracket, to the power of however many years we have left the investment in the bank, or however many years we have owed the debt. So F for final value, P for principal, which is our starting value, how much we started with, I is for the interest rate, and T is for time, usually in years. But the interest compounding time and the time we measure in has to be the same. So if our interest rate is per year, then we'd want to measure our time in years. If our interest rate was per week, we'd want to measure our time in weeks. Let's have a look at how we structure these problems. So we use these diagrams, these lines that have our years or our time periods counting up. And to begin with, at the present, we're at the beginning of year 1, which we can call time 0 or year 0. And that's where we have the principal, the amount of money we start with. And if we think about an investment, so we start with a particular amount of money, we put it in the bank, and after 1 year, the bank gives us a particular amount of interest. And how do we calculate that interest? Well, we were told a particular interest rate, so that means a particular percentage of what we originally put in gets added on. So that means that the amount of interest we get is the interest rate multiplied by how much money we put in to begin with. So that's going to be what we started with plus our amount of interest that gets added on is what will be in our account at the end of year 1 when the bank has added on our extra piece. If I take out the common factor of my principal, if I do a little bit of algebra and take out the common factor of my principal, then I can see that my final value at the end of year 1 is equal to the principal multiplied by 1 plus the interest rate, and there is a little power of 1 there that we haven't necessarily needed to write. And perhaps that gives a guidance as to where the formula is coming from, this formula that we're going to use. At the end of year 2, we would be able to do some more maths like this to show that the final value at the end of year 2 would be the starting value, back here, times 1 plus the interest rate to the power of 2 for 2 years. So that's our formula in practice. We're going to do the following question about Susan's investment 2 ways. We're going to work through it step by step, and then we're going to use the formula. So let's get into it. Susan invests €2,500 at 11% interest per annum. Per annum means per year. So annually would mean to do something once a year, and per annum means per year. So Susan invests €2,500 at 11% interest per annum. How much is it worth after 2 years? So anytime we get one of these questions, we recognize we're talking about compound interest, so we write down our formula. We go to our formula tables, we write down our formula, like so, and we're going to write down all the information we're given in the question. So we're told that Susan invests €2,500. Well, that means that's our starting amount of money, 2,500. and we're told that the interest rate is 11%. So that means the percentage interest rate is going to be 11%, and I immediately turn that into a decimal. So 11% means 11 per 100, percent per 100. I put that in my calculator and I get 0.11. I always do this instantly whenever I get an interest rate. I'm never going to do anything with the percentage. I will always immediately turn it into a decimal when I write it down. So this immediately gets written as a decimal, never ever left as a percentage, just turned straight into a decimal, and then we do work with it. And then finally, we're told that this happens for 2 years, and we're given a yearly interest rate, and we are told our timing years, so our interest rate and our time work together, and we're looking for our final value after our 2 years. So let's draw our picture to keep track of what we know. So we start off in the present at year 0. No time has passed. After 1 year has passed, and then after 2 years have passed. So currently, I'm at the principal stage. I have Susan has €2,500. And then at the end of the first year, we're going to have added on a particular amount of interest. We're going to have added on the interest rate, our 11%, times what we started with. So we have our amount of interest we get is going to be 11% of what we put in to begin with. And that gets added on to what we had in the bank originally, the 2,500. And then we'll do the same thing or a similar thing for calculating how much gets added on in year 2. But let's get our final value for year 1 before we get into that. So we're dealing with year 1 now. So we're looking for our final value for the first year. And we can see that that comes from what we started with. So final value for year 1 would be what we started with plus 11%, which we've already turned into a decimal. We know we don't do anything with it as a percentage, multiplied by what we put in to begin with. And when we calculate that, our final value at the end of year 1 is going to be €2,705. So that's how much we have here at the end of year 1. So F1 ends up being equal to 2,775. And how are we going to get how much we have at the end of year 2? Well, this is our new starting value for the beginning of year 2. The end of year 1 is the beginning of year 2. So now our principal for year 2 is going to be our 2,775. So it's going to be 2,775. And at the end of the year, for F2, we're going to have added on our interest. So our 0.11, our 11% of what we had at the beginning of the year, 2,775. So this is how interest compounds. We're not going to add on this amount each year. We're going to find 11% of what was in the account at the beginning of the year and add that on at the end of the year. So as time goes on, as the amount of money in the account grows, we're getting 11% of a larger and larger number. So our money builds up faster and faster and faster, or bigger and bigger and bigger. We also need to be aware, if this was a loan, the amount we would owe would also be getting bigger each year. And the amount it was getting bigger would get bigger every year. So let's find our year 2. So we want our final value for year 2. Well, our final value for year 2 is going to be what we had in the account at the beginning of year 2, which was the end of year 1, plus the interest that we get on. So our principal for year 2 was our final value for year 1 plus our interest 2775. And when we do that, we get final value at the end of year 2 is 3080.25 euro. So that's how we can structure our question. Now, if we have a situation like this, where the amount of money in the account is just gaining interest, it doesn't get changed. So Susan didn't come in and take out €1,000 after the first year or something like that. If the money just gets left alone to earn interest, then we can use this formula to do the job faster. What we can do is say, well, our principal is €2,500. Our interest rate is our 11%, which we know we immediately turn into a decimal. We did that over here. And we're interested in keeping it in the account for 2 years. And we want to know the final value at the end of 2 years. So then we can actually just sub into this formula and set the time equal to 2 years. It'll be 2,500 on 1 plus our interest rate. So we should write the formula down immediately before we sub into it. P on 1 plus I to the power of t. And when we sub that in, we have our principal on 0.11 to the power of 2. And when we put this block into our calculator, we get the exact same answer. But we need to be careful of this formula because it only works when the money is left alone at the same interest rate with no money being added or taken out, separate to the interest that's getting earned. So if it's like this, where every year interest gets added on and nothing else happens, then we're able to use this formula over that period of time to find out what our final value would be. But if there's any change made, if Susan adds money, takes money away, or if the interest rate changes over a time, then we can't use this formula. We have to do it the longer way and tell ourselves the story. So that is what we need for now.